which I'm not going to show you today. But most importantly, rather, let's appreciate this huge, water source. 14 great mountain ranges, world's 100 highest peaks are located above 7,000 meter mean sea level. And then the highest and the largest plateau ever existed. And then also not to forget that, although this is today is a source of not only water, but a lot of other materials, as you can see from this image also. Here, I think you can manifest what I said a little while ago, that how the source sustainability is important to look at the, destiny or the state of the delta, because you can clearly see the material coming down, although it's a very, very, not even a bird's eye view, but a much more of a satellite point of view. But the connectivity is very clear. And you can visualize so many people are residing in between those lands, and how then, the issue of communities and livelihoods and, and diplomacy, sharing of water, all that coming. So this is something very, very important to realize, that the third pole, as we call it, where more than 46,000 glaciers are located. The scales are actually mind-boggling. And you can at least visualize one glacier and then multiply by 46,000. And you can realize the kind of freshwater that is locked in there. And the largest number of glaciers beyond only the Arctic and the Antarctic. And then the kind of melt that is actually feeding all the Asian great rivers. It's basically more of a island of snow mountain in the sky up there, and it also actually acts as a atmospheric cooler. So its role in climate change, or affecting or kind of offsetting the global warming is also very, very important. I'll not really keep spending too much of time on each slide, because part of these things hopefully are you are knowing a little more or less. At the same time, one has to realize that how this is called also the barometer of Asia. The entire issue of temperature, pressure, precipitation, and how these westerlies and the Indian monsoon and the Asian monsoon all come together. In fact, this is a location where a lot of disasters happen in terms of typhoons and cyclones and all that, because this trijunction is extremely important. On the other hand, I must also, while passing, should mention that because of this creation of the water tower of Asia, the process of this, plate margins and the whole collision happening, it also happens to be the most unstable and tremor-prone region of the world. So all the rivers are actually getting kind of suspended in a sort of a shaken or shakeable table, and then you can realize that how these rivers are constantly adjusting to all these changes happening, the hydrological changes, the atmospheric changes, the tectonic and the seismological changes. So these are some of the most unstable river of the world. That's why you can see the braiding, the kind of irregularity, the kind of unpredictability of these rivers, and how then they play havoc when they go down in terms of flooding and flash flood. Some of my students will throw light on material transfer and flash flood and all that. So it makes it very, very pertinent that the lesser amount of disturbance to this equilibrium is actually good, because already it's a highly disturbed kind of a hydrological landscape. And then you start realizing that the kind of terrestrial fauna, flora, and diversity that it supports. I'm not going to name some of these like the snow leopard and all that, but there are 5,760 species of plants which are identified. Equally, there are a number of animals there. So all these fauna is uniquely suited for a particular altitude. And then you will see all these kind of very, very exotic species like the astronauts on the wing and stuff like. So it talks about that why these areas should be protected for more than one reason, not only as a source of water, but also as kind of unique biodiversity and the terrestrial habitat that it supports. And not to forget that all the downstream terrestrial and other aquatic kind of life forms are very, very intrinsically connected to the kind of mosaic that flows down these rivers from the water tower of Asia. This is a picture looking westbound from eastbound along the axis of the Tibetan Plateau. On the left, you can see the Himalayan mountain ranges, and you can also see where Mount Everest, where Kanchenjunga is, as well as the trail of the Yarlung Jangbo, the origin of Brahmaputra. apart from, the Kailas and the other side, the Indus and all that. So again, kind of fill up this place to just tell you that how Asia's 6 greatest rivers are actually flowing down from the Tibetan Plateau. And not only that, they're flowing to some of the most populated regions of the world, and they're supporting almost half the world population in terms of their livelihoods. Now, that's really something only one can comprehend when you apply your mind to realize that a 6 million square kilometer drainage basin filled of some of the most populated pockets, and what sort of, interrelationship this hydrological landscape can have with cultural landscape, with biodiversity, with all that, and linking to finally, the overall utility of this water in terms of a lot of engineered interventions like hydropower and other kind of, structural interventions. So Yangtze, which is Richu, Yellow, Machu, then Jachu, then other rivers, they're all like, we know a lot about them downstream where population have been there. You have a lot of figures about them. You realize that, for example, Indus get almost about 50% of its glacial, water flow from glacial melt. On the other hand, only about 12% is for Brahmaputra, 18 from Yangtze. So you realize that how, again, a differential manner, these glacial sources at the water tower of Asia actually again influence the flow. And we must recognize that this is mostly during the lean flow when the monsoon rains are not happening, that the sustenance of all the downstream flow, along with, of course, storage in canopies, in groundwater reservoirs, all these water really come down. So you can see some very interesting figure in terms of the, you can say the, people-centric utility of this water that, for example, the highest per capita water is from Selwyn, 7,876 cubic meter per person per year. That's really very big. But Ganges, if you compare immediately, you realize it's only 932. And it talks about that how intense utilization of these rivers can actually finally deplete the per capita availability of water. And then it implies a lot in terms of your drinking water, your irrigation water, the other utility water, and how despite having these big rivers, we are already facing a relative water stress. And at the same time, if the headwaters tomorrow for differential reason get depleted, what sort of havoc it can play to the 932 cubic meter becoming maybe 500 or 400 like that. So it speaks volume of the kind of care we need to look at this water. And then if you start looking at the processes, the hydrological processes, which is actually governed by primarily physical processes, but also then it start influencing the chemistry of the water, the biology of the water. You realize that the Tibetan Plateau water tower actually churns a lot of this, water vapor transportation happening from the plain area of Indian Ocean and the Indian landmass, and then how it again recirculate it into a lot of processes in terms of dissipating them into different atmospheric direction. At the same time, converting a great deal of it into precipitation and those water flowing down to the river like Indus and Ganga and Brahmaputra and other 3-4 rivers. I have not even talked about other minor rivers like Iravati and others. There are plenty of other rivers also where a large amount of kind of a potential for different kind of development actually lie. So when you look at this river basin and you start looking at its hydrological significance and the allied significance of its supporting lifestyle, you start realizing that comparative to even our immediate neighborhood in part of Europe and all that, you realize that we are actually, given or kind of, um, sort of influenced by a colossal amount of water, provided we use it well and we actually look at their sustainability. So there are this scale of high to very high to moderate to low significance. And also, you can look at that of what sort of, um, lot of related influences that can come out of this huge mass of cumulative water that is there in the Tibetan Plateau. Now, when you start looking at what role does it play, and many of time, some of these roles are not very visible to our eyes because we are far away and we also do not think at that scale. So typically, if you look at, and there are very beautiful paper by Walter and others to show that how the influence of even global climate change in terms of temperature, precipitation are quite variable to the Tibetan plateau, even compared to the Himalayan system, or definitely for the floodplain of Ganga Brahmaputra. So the Indian monsoon system, the westerlies, the Asian monsoon system, and a lot of this local moisture recycling, all these are actually affected by the Tibetan plateau. And then if you look at that, what sort of precipitation trend or temperature trend is happening, as I said, I mentioned only Walter, but there are many other workers showing that how there is a differentiality in terms of temperature rise, global warming, as well as the precipitation behavior, and then as a resultant, all sort of hydroecological responses. So you realize that the increased rainfall, in terms of richer water released from Tibetan plateau to downstream area. So there is a sort of apparent water availability in Asia, being amply kind of endowed by the Tibetan plateau. But unfortunately, that's really changing. So a lot of studies, and it's really pretty complex, I would say. And as of now, very few conclusions could be drawn emphatically because a lot of uncertainties are involved. So you see that the glaciers cover about 10 to 20% of the total area, and the additional 30 and 40% also has a seasonal snow cover. So when you realize that, including Tibet, the Himalayan glacier cover around 100,000 square kilometer, storing about 12,000 cubic kilometer of fresh water and 43,000 square kilometer glacier alone. And you realize that there is a altitude relation to that. How above 4,000 or 3,000 meter is only 0.3%, but around 6,000, you have got about 50% almost, glaciers are located. So that is how they keep storing this water. But at the same time, you also realize that the topography and the glacial cover of the Tibetan plateau is very variable. Up there, I'll show you a couple of distributed lakes, which are like contained lake. No water flows out of it. They're within a plateau. On the other hand, in the peripheral fringe area, bordering Himalaya, many of this water actually come down. So there's always this, the mass balance is getting sort of affected, and how then the glacial health, the source of the headwater, eventually dictates what will be happening to the rivers and streams and springs and all the water flowing down below. So because of this global warming and climate change, and you can see a lot of these studies about black carbon, black soot, how these are absorbing more heat and then kind of, you can say accelerating the melting. So there are a lot of these finding are talking about, including China's Minister of Water Resources, that as many as 28,000 small glaciers has abruptly disappeared by 2011. That's really very worrisome. The diminished glacial runoff had already reduced water levels in the Yangtze River. Unfortunately, as a researcher, we must understand and admit that the amount of studies, amount of science that is needed to understand such large colossal system is still not there. So it's almost like based on some random discrete engagement, we are trying to extrapolate a lot of these thoughts. For example, if you look at Gangotri, you realize that this is one of the very established kind of a glacial recession happening from 1780 to 1935 to 64 to 71,001, and even currently we are monitoring Gangotri. But that you do not know about those 30,000 other glaciers, whether we really are looking at them very carefully. I'm glad to share with you that we have just been given a fairly reasonably, good project on glacial behavior of the Eastern Himalaya in Arunachal. Many of my students will be working, will be hiring also project staff to look at the glacial dynamics of the Eastern Himalaya. Again, as I have maintained, we are not really going to look at it, in terms of field engagement, but it will be more like a study from satellite maps and remote sense, techniques, because it's too large a system for us to engage quickly and come up with some you know, for reaching conclusion. So it will be more of a preliminary engagement on the glacier of the Eastern Himalaya. And I must say that it's just a very small subset of the large glacial landscape that we have, and also the hydrological landscape. This is something you can appreciate, that these are what they call, endorheic basin. Endorheic basin means that the water never comes out of the system. They're onto themselves. So this water falling in the whole plateau area, and you can visualize it to be a flat, fairly flat land. All this water are actually getting its destination to some of these small and big water bodies and getting contained there. It's not that this water is not coming to the Mekong or Yellow or Salween or Brahmaputra or Ganges. But the water that is coming out is from the fringe area of the glaciers, which have a slope, which have a movement. So you can see that these lakes are also important in terms of, again, in a very limited time, let me say that there's a huge connectivity of, groundwater and surface water, and they all percolate down, and sometime water comes out of the system. But as I said, the endorheic basins will not be doing that. These are all contained within, but it has an implication. Within the plateau, you will see that there is a whole complex pattern of lake volume change. So if you look at a large time window from 70s to 2015, there is about 2.78 gigaton per year of, decrease in the glacial volume, lake volume, sorry. And then, in a shorter time window, you can see there are some perturbation like increase also. But again, on net, you can see that there's again a deacceleration of 1.46 gigaton per year during 11 to 15. So within that spectrum, there are also a lot of irregularity, and it's not very easy to really decipher that what exactly is happening, because you'll see in another slide, there's a shift of this whole water volume pattern also in the lake. So terrestrial water storage, if you look at the lake water, the glacier, the soil moisture, the snow water equivalent, the groundwater storage, if you put all this together as the whole set of the water we have, a lot of internal adjustment among them. So that's why very specifically telling what is happening is not easy. We can have some figure like this study by Zhang and others in 2017, that the Tibetan Plateau groundwater storage have increased from 5.01 plus minus 1.59 gigaton per year over a period of about 6 years. Now, that means that this water is somewhere getting locked up in the groundwater, not coming out, and that means somewhere that could have an implication to the flowing water. So similarly, increased net precipitation contribute to many of the water supply, 74% of this lake volume increase, followed by also the glaciers losing some of its mass, about 13%, and also the ground ice melt due to permafrost degradation, about 12%. So one can see that within the larger Tibetan Plateau, a lot of these changes are happening, and the hydrological cycle in the Tibetan Plateau has sort of intensified remarkably during these recent decades, and that can have other sort of implication to the water flowing out of the plateau fringe and to the Himalayan system and to downstream. So it's necessary to look at these dramatic lake changes from 70 to 2010 with sort of a shift southwest to northeast transition from shrinking to stable to rapidly expanding. That means, see, a lot of drama is unfolding within the Tibetan Plateau, which itself is a huge area, and we are still to decipher how these changes may be actually influencing. Not to forget that all these lakes will undergo evapotranspiration. There will be again local cloud formation, local moisture formation. It can move along with the wind, and it can finally again, condense and precipitate at some other location, which can have an implication to the flowing water. So the limited role of glacier melt and the potentially important contribution of permafrost degradation in the predicting the future water availability in this region is related to this particular lake landscape, which of course, I would not say directly implicated in terms of the water that is changing in the river, but because water systems are both meteorologically and in terms of groundwater, in terms of surface water are connected, we have this climate variation and these linkages, how these meteorological stations are giving different kind of trends. You can see that how the map is showing, the shift in the average zero temperature isoline and other factors like evaporation and stuff like that. Today will not be really an opportunity to really very micro way to look at all these figures to decipher. But my today's point will be that changes are happening. There are climatic influences happening. There are responses happening. There are proxies that you can witness to decipher and kind of conclude some, at least some early conclusion, which can be, I would say, integrated into policies, into larger policies. Nobody knows the Tibetan Plateau, the water tower of Asia, who decides the policy, but because it is source of so many rivers shared by so many countries, these rivers are, it needs a kind of a collective discussion at some point of time somewhere, which I don't know right now where it should be. So you can look at this contribution of rainfall and snow and groundwater to the total rain of this river, which is you can say more of a concern of today's discussion, that how the glacier model called the VIC glacier model is telling us about the share of these different contributory component of water to Yellow River, Yangtze River, Mekong, Salween, Brahmaputra, and the Indus. And as you have already noticed, perhaps the Indus River have almost about 50% contribution from the glaciers, but the other rivers, of course, the glacier contribution is less. But yet, the rainfall, which is monsoon, and when we talk about precipitation, we do not really distinguish between whether it is a snowfall or rainfall. Eventually, both are water, and they eventually sustain the headwater of these rivers. Those of you who are interested, and my students are already, Juna in particular is working in the glacial landscape of the Tawang area of Arunachal. So we are looking at this change of stream flow on the Tibetan Plateau, not Tibetan Plateau, but the landscape that we are looking at. And you can see one thing, that a lot of gaps, precipitation, meltwater, groundwater, many figures are missing because we don't have the figures studied so far. So that's why the picture is not really complete. We are still kind of a progressive science where we're trying to look at, some of these parameters with more and more objective data to get more and more dependable conclusions. You can also see the chemistry of it. The chemistry of the water, you may suddenly get startled, oh, Jangbo, Changpo, or Jangbo they call it, almost kind of more than 50% ions are chloride. Now you start realizing where this chloride comes from to a river that is flowing basically a fresh water, But then you should not forget that the Himalayas and the Tibetan Plateau also was a seafront. The Himalayas have risen from the sea bottom. So a lot of these rocks, a lot of these, soil and other materials are actually once upon a time was under the sea. So there are a lot of chloride. You can see that whether it is Yangtze has so much of chloride, you see. But then as it comes down, because many of the streams and tributaries join Brahmaputra or Ganges or Yellow or Yangtze, the final water, if you measure, for example, Brahmaputra, where I am right now located in Guwahati, there's not as much of chloride. It's just kind of, diminished and neutralized and rather, I would say, diluted. But when you go up there in Tibet, there are beautiful paper by Hu Ming and so a lot of workers, early workers. You'll see that a great deal of sodium, sulfate and calcium sulfate salts are there, halides are there, which actually render a very different water chemistry. So even if we don't count for the trace metal and other nutrients, even if we look at this major cation like calcium, magnesium, potassium, sodium, and bicarbonate, sulfate, chloride, and nitrate, you see a very differential chemistry again. And mind you, this chemistry eventually support the aquatic flora and fauna. They decide the habitat of the dolphins. They decide the health of the river. So over a period of time, these chemical changes do a lot of readjustment, and accordingly, the responses of the biodiversity or all the other supported terrestrial ecosystem can undergo changes. So some of this chemistry, of course, as you can see, this paper also, water quality in the Tibetan Plateau have been studied. This is a 2019 paper, but I was mentioning about Hu Ming. This is, I think, is a 1982 paper. Yeah. So since then, this is going on, and we are looking at what sort of changes are happening. As of now, it's understandable that there are not too many toxic metals truly, but there are reports that even downstream of Lhasa in some areas there are loads of urban contaminants are coming, and the water quality indices are getting affected. Uh, so if you look at these physical processes, chemical processes, biological processes, the glaciers, the precipitation, all put together, some of these people like this Q et al., they are looking at Tibetan Plateau, and the Chinese Academy of Science is also looking at. We are peripherally started looking at the Himalayan part and the peripheral part of Tibetan Plateau as receptor of some of these waters. And you can see that the water shortage can cost the country less than 40 to 60 billion RMB, that is in China. So they are worried. China's Ministry of Environmental Protection is looking at, that what kind of, implication to drinking, swimming, and fishing, etc. can happen. Similarly, the annual rate of glacial melt in Tibet is about 7%, which can result into all sort of recession and diminishing of the glacier. A lot of projections are happening by 2050, by 2100, a lot of change can happen. And also, not to talk about environmental degradation, human interventions are increasing into this water system, the hydrological landscape. I'm not even going to talk about what have been the relationship of the nomads vis-a-vis the water, and how they have been kind of coming in terms with the overall hydrological landscape of Tibetan Plateau. But even if you look at some of these papers like Jean et al. 2008, there are degradation of permafrost happening, and they all are having uncertain future implication. Similarly, a lot of talk is happening in terms of irresponsible water resource extraction and other kind of anthropogenic activities. There are reports of some of the tributaries like the Pig River of the Yellow River, that's a tributary. Similarly, Yangtze, um, I have been there, a couple of these rivers, and standing there, we started looking at them, the kind of sand mining and all that. Well, there are good lessons, bad lessons, and we always think that coming back, some of the good things can we do it to our rivers here also. But you can see that there are, increased industrial activities. Then definitely a major issue, although it is highly contestable. There are geopolitical issues, but at the academic level, there is a need of a discussion that what sort of larger global policies should happen in terms of maybe intervention for hydropower, how both the Indian landscape and the Tibetan and the Chinese landscape is getting affected by some of this intervention, and what prudent things can happen. It's not easy. There are always shifted priorities. So, and many of these topics are very contentious and contestable. We cannot really give a very one-sided comment also when you take a very neutral stand. But the truth is that the impact on the rivers of the Tibetan Plateau is happening. And there are serious implications to that. ICMOD being in particular located in Kathmandu and being funded by all these countries of Asia, they get funding from India, from China, from other people also. And they're looking at the Himalayan and the Tibetan system in a more of an academic way. And there are many, many reports you'll find. If you go to the ICMOD site, they have been constantly bringing out reports on the health of the Himalayan and the Tibetan system, particularly Himalayas, and also then the health of the glacier, the springs, the streams, the rivers, the tributaries, and all that. So clearly, many organizations who are concerned, like WWF being concerned with nature conservation, are talking about what sort of aquatic and terrestrial, systems and the species and others are getting affected. Similarly, some of these um, places where human beings are consuming the water, like the tap water in this Kumbun monastery, again found that there are implications of mine pollution happening. So my point is here that this is a global heritage, and there has to be some sort of consensus to come together to protect it, because it will be loss of everyone. If tomorrow, if we look at this whole, the Tibetan Plateau and the Himalayan system under peril, um, people will not realize. Our diplomats will keep negotiating water between different countries, but water itself, both in terms of quantity and quality, will not be there. So I guess the hydrodiplomacy should also somewhere focus upon the engaging into negotiation in terms of protecting the headwaters, protecting the upstream, taking care of collectively the best management practices for not allowing this water to go bad in terms of mining or all kind of interventions. And that's not easy. A lot of international bodies are trying to do so, but our anthropogenic priorities, if I can call it, is so different that it's a here and now syndrome. We don't care much about because it's not happening in front of my house right now, and it's not happening now. People are talking about 10, 20, 50, 100 years. So, uh, there is a sort of a, I would say, kind of a, the ostrich putting its head under the sand, and we're not looking at it. We're looking away. But there are a lot of other discussion. You'll find that how these nomads have been having some of their very nature-friendly practices, and how different grassland policies are evolving. They are being criticized also because of this concern. Then what sort of then policies should evolve. All discussions finally go towards that how at least some of these academic institutions of these different countries in the first place come together and start looking at the glacial retreat, the temperature rise, the carbon balance, in the Tibetan Plateau, and create a better model to understand the warming trends, the impacts on the permafrost, river flows, grasslands, desertification, and all that. So, so what we're talking about right now is that let's at least start sharing the data. Let's at least start looking at some of the mitigation models. Governments of different countries, can they engage for some sort of retweaking of some policies, which is like better for a larger populace, a larger landscape, and then can we create some of the regional framework? That how many people are doing that. For example, the Mekong River Commission, multiple countries are part of it. We know that part. I am today not, although I have been part of Asian conference in terms of been engaging into some of these organizations. We had a very fruitful trip a little more than a year back to the Mekong River Commission, and we looked at Mekong at different countries. But then I don't know, even Mekong is not perhaps looking up as much to upstream as it should be. So there are different, I just thought I'll quickly show this, that there are different, I'm sorry the power has gone off, so I hope you're listening. Am I still audible?
Yes.
Yeah, okay, that's good. But right now power has gone in my room, so I hope it will come back. So there are these regional river basin management framework where you can see how there's a whole information gathering to look at, water availability scenario, risk management, and then talk about the kind of integrated management. Unfortunately, most of these models are still bookish, still contained into discussion and discourses and textbooks. But of course, it is now spilling over to the community, and I must say Asian Confluence is thankfully playing a very leading role in doing that, and where we can actually talk about institutionalization of this sustainability principle. They are emerging, but I'm sure they will spell one of the future direction, maybe for betterment of the situation. Well, as you know, I mean, if you all engage into a discussion, everybody can come up with interesting suggestion knowing the problem. But we are saying that we need to look at the current policies and how they can be sort of, um, aligned into some of the sustainable development goals and other good things that is emerging. Then how you can engage local communities who are already apparently doing things in a good way. And then, well, it's very difficult to now say that, okay, move away from water heavy coal to fossil fuel option and all that. But, you know, there are a lot of this need of warming up bilateral relation. And now, of course, there are multilateral relations is also happening, at least to address the water issues, the water tower issue. And how then, that is where I often get confused even about the engagement of the Asian conference into the diplomacy part, the hydro diplomacy part, that, the fundamental question that do you teach the diplomat the waterway, or do you create, a lot of water specialists with a sort of water negotiation skill, or do you look at even a new generation of um, kind of graduates coming out with kind of required training to do justice to this sort of very complex terrain, very complex kind of hydrological landscape and hydrological system. So I'll stop at that. I must say that it's really these discourses are mostly inconclusive, because you don't have just one answer. If you put into, it's something like one size doesn't fit all. So if you put into the shoes of somebody, one country, you realize that their perspective is very different. China will try to perhaps immediately amend its problem of drying up in the Gobi Desert region. Even there are all sort of speculation about, taking water from south to north through a lot of interventions. Similarly, we are realizing that the landscape on the Indian side, particularly in Assam, where I am, I can see a lot of changes happening in front of my eyes over the last 2 decades. And they're not in a very encouraging way. So that's something we really need to look into. While we need to look into our local practices, our local wrong practices in terms of water saving technologies, and in terms of sustainable practices for water, but we cannot forget the big picture. We should not miss out the headwater part. So whatever is happening at a very large scale, at a diplomatic level, well, only a few handful people will be engaged into, but we have to kind of keep adapting to, keep adjusting to the change scenario upstream. That's very important. Keeping that in the perspective is very important. When we are drawing up local plans for water supply, that water supply intake in Brahmaputra could be unpredictable because of 10 years down the line, lean flow variation has to be kept in mind. I can tell you from my personal experience, a lot of water intake of a lot of water supply, urban water supply, went dry because we located in the wrong place, and those places got dried up because of more material coming in, breeding, landforms happening, the river shifting out, and all that. And while we cannot really correlate it to what is happening in the Tibetan plateau, I can tell you from whatever pragmatism I have developed over these years, engaging into hydrology as a premise. On that, we built up eco-hydrology, environmental part of it, water treatment part of that is different. But the larger landscape issue, if you look at, we realize that there is a link, there's the interconnectedness, and that cannot be forgotten. So today my attempt was entirely to just kind of, again, I can come back saying that how the health of the headwater influences the character of the confluence, and how the sustainability of the source actually determines the overall, general goodness of the water at the confluence. So the destiny of the delta. Maybe in this platform or in future, we'll try to look at two more important things. One is what's happening in all the Asian confluences, particularly starting from Yellow to Yangtze, to Salween, to Irrawaddy, to Mekong, to Sundarban, to Indus, all that. And my students like Juna is working on Glacier, but another student, I don't know whether Lakshmi have joined or not, she's working in the Indian Ocean. So we are looking at this system from a very large perspective of to the mountain to the ocean. And some of these points emerged out of that curiosity a little more prominently than others. And perhaps that's why we'll try to play a role that today we have talked about the source water, the headwater. Next, we may talk about the confluences. And maybe we can even talk about the entire landscape in between. As the water flows from mountain to the ocean, along the way, in the further floodplain perspective, what are the things happening? How then it affects people, our lives, and our future? I'll stop here. I don't know how much time I have taken, but I thought that these are few points that we should flag. And I have 4 students lined up among many of my students who will now kind of, keeping the broad theme in mind, but not necessarily restricting them to that. We'll be talking a little bit like Abhishek will start, then others will follow. But that I think we can then go on to the next speaker. Unless, Sabda, you have any other plan? Can Abhishek directly take it up, or you have anything to intervene in? Unless you want to make a small comment.
No, I just want to first. I think you very beautifully put forward the importance of the headwaters. I think it's not adequately represented in the hydrodiplomacy that exists in the region, or even in the hydrodiplomacy globally, because this is a global heritage. It affects the global picture essentially.
Yeah.
And you asked a question about, do you train the diplomats, or do you train civil society, or do you actually produce more research? I think we have to make it a multi-pronged Hydra effort.
Hydra effort, right?
Yes. And I think we need to collaborate and work together in that spirit. The various institutions, what we call in Asian Confluence, forge a third space to have this Hydra effort, where we really think about the future of the planet, a more common sense approach to understanding and dealing with the problem. It is only then, I think, that policy can be influenced, and then the geopolitics can be influenced. So on that note, I think we can go over.
We do keep discussing this. Like Saturday is actually our weekly meeting with the research group, and many of these points emerge. You can think that today basically we have opened up our research group to the Asian Conference. Primarily, these are the things we keep discussing. We talk about river health. We talk about so many other nuances of hydrological system, groundwater as well. So yeah, I mean, we are at our level. We are looking at, but I'm sure Asian Conference can at some point take up this also as a good mandate. Yeah,
absolutely. I think we should, and we should, and we will together. I think let's plan very definitively on that front. We'd love to hear from the wonderful work that your students are doing. So I think back to you, Chandan, for moderating the session with the students. I think you're muted, Abhishek.
Abhishek, yeah, you have to unmute. Yeah, right.
Good morning, everyone. Professor Mahanta has talked about this region from the water perspective, and I intend to present this region from the different perspective, the sediment perspective. Generally, in a more general sense, the sediment is quantified in a broadly 5 scientific themes: where it is coming from, the source and provenance, where it is, what is the process that is subjected to, how they respond to the disturbances, both natural and man-made, and what paleo information, the paleo climate, paleo drainage, paleo environment information that we can extract from those sediments, and what is the physical and biogeochemical processes that are occurring between the sediment and water, and sediment and the ecology. And this is the layer of understanding that we develop here, and that layer of understanding, through a mechanism of mapping mechanism, we try to apply that from 3 different perspectives: the environmental perspective, the earth science perspective, and water resource perspective. The health of the ecosystem, the ecology, the climate change, delta sustainability, as we know that the sediment is the only combating force to combat the sea level rise, morphological changes, erosion problem, hydro and irrigation projects. So all these things, the first layer has the implications in the second layer, the application part. As a researcher, we try to work on this first layer where we try to understand the system in a better way, and conferences like this and interface like this help us to identify the mapping mechanism, how this understanding can be applied to the real field problems. If you talk about the issues of sediment, the quality and quantities issue. If there's too much sediment, then there's a problem. If there's too little sediment, there's a problem. Too much sediment creates problem for the hydropower plants, sensitive aquatic habitats, the oxygen supply for the aquatic, the flora and fauna, and the too little sediments undermining the roads, bridges, and other infrastructure gets problem. Then delta and estuary, wetlands, flood salts, all these things got degradation. If we talk about, I just present you the global synthesis of the sediment fluxes to the world ocean. 19 billion ton of the sediment is delivered to the global ocean. And what is interesting to see that 2/3 of the global sediment is coming from the southeastern region. So we are talking about the water tower here. We have right here a sediment tower. Almost 2/3 of the sediment is being delivered to the ocean from a very small area. And if we focus on the Southeast Asian part, we'll see that out of the Southeast Asia part, half of the sediment is delivered by the 3 countries: Indonesia, Philippines, and Taiwan. So right here, there's one more sediment tower. Taiwan is little dot here. This is heavily erodible landscape, highly eroded. And because they have a young Cenozoic sedimentary and volcanic rock, they get easily eroded. So the 40% of the global total, the 19 billion ton, and 40% of that coming from the 2.5% of the global land area. And in the subsequent slide, I will show you that even out of 2.5%, there's a small hotspots of the sediment delivering zones. I talked about the Taiwan. So if you see the sediment yield, the million ton per kilometer square per year, the annual sediment yield is the highest for the Oceania and Oceania region, the Taiwan, the New Zealand. All these countries' rivers eroded very faster because they have a very young and the climate is such that they are eroding very faster. But Brahmaputra comes in terms of the sediment load, it is coming around the 520 million ton, 544 million ton for the Brahmaputra, 520 for the Ganga. Comes in the 3rd and 4th position respectively. This was the one global database. There are many other databases, global databases, which have given the similar kind of a figure, the 20 billion ton or 19 billion ton. And if we see the contribution of these, the contribution of Ganga and Brahmaputra in these databases, we will say that the 540 is the figure that most of them apply, and 520 or 570. So these are the contribution to the global database. There are regional studies as well, which has prepared a sediment budget for the Assam region, like the Goswami's paper, famous Goswami paper 1985, and Mahanta and Saikias in 2017. They said that 782 million ton is a suspended sediment that is leaving the Assam region. And 782, when it reaches to the Bhadrabad in the Bangladesh, it becomes 721, and even downstream the Mawa, after the confluence with the Ganga, which is still 45 kilometers upstream of Meghna, we have the sediment load of 524 million ton per year. And what happens after that, we do not know exactly because there are no direct measurements. However, they have used cesium and lead isotopes to determine the sedimentation rate, and they figure out that 30% of the sediment deposited in the river floodplain part, 41% reaches to the subaqueous delta, and 29% of the 1 gigaton, the 520 for Ganga, 540 for the Brahmaputra, out of 1 gigaton, the 29% reaches to the deep Bengal Ocean. So this is if we join all these kind of studies and club them together, then this is the sediment budget that we come across. But what are the trends? How the sediments flux is changing over time? Initially, when they applied different models, they said the sediment trend is increasing because of the climate change. But recently, when they introduced the upstream plant dams in the hydrological model, they found a decreasing trend. And recently, Rahman's paper, they used the historical data. They did not use any model, but they used the historical data of 50 or 60 years, did some trend analysis, and they said that the Ganga is decreasing. Ganga is facing decreasing trend of 4 million ton per year, and Brahmaputra is decreasing at a rate of 5 million ton per year. And think about the implication it will have in the on the delta sustainability if this carries on for the longer period of time. So the only implication is that the upstream plant dam have reduced the sediment delivery to the ocean. Sediments are very interesting matter. They provide us a lot of tools to explore them. So physical tools, mineralogical tools, magnetic tools, geochemical tools, biochemical tools, the fallout radionuclide, cosmogenic tools, very high, very sophisticated techniques that we can use to explore the sediment and answer those 5 questions: the source sediments, source of the sediment, the processes, paleoclimate understanding, and all these things. So these tools have been explored in the Brahmaputra basin. I have segregated the studies in 3 different regions: the Yarlung and other rivers, Brahmaputra, and Bengal basin. Most of them have been explored, but such few studies such as magnetic properties have not been explored for the fluvial sediment in the Brahmaputra basin. And it opens up the possibility. The research question: what are the things that we want to know about the Brahmaputra basin? The first is, what is the contribution of various units to sediment budget in Brahmaputra basin? Because Brahmaputra is a dynamic river, its behavior changes in space and time. So what are the processes that the fluvial sediments are subjected to? In the last few decades, as I talked, series of water resource and irrigation projects have been installed and quite a few are planned. So how the sediment nature or quality and the quantity have been or will be affected by the anthropogenic disturbances. Yarlung, Sangpo, and Brahmaputra are the 2 very different rivers in terms of geography, meteorology, hydrology, and geology. Were Brahmaputra and Sangpo rivers always the one river, or due to the tectonic uplift and river incision, Brahmaputra captured the Sangpo? And if yes, then when? And then how Brahmaputra sediment flux erosion has responded to the paleoclimate changes. The interesting thing is that if you talk about the source of the sediment, the 30% of sediment in the Brahmaputra is from the Trans-Himalayan Plutonic Belt, 60% is coming from the Himalayan Belt, and 10% is coming from the Lower Himalayan Belt. And if you talk about in terms of the basin, then 81% of the Siang sediment and Dhubri, if you see here, the Pasighat, the 81% of the sediment is from the Siang sediment, and then it starts diluting, but still at Dhubri, if you see, 58% of the sediment at Dhubri is coming from the Siang basin, that is right here, the eastern syntaxis part. So very heterogeneously, the focused erosion is taking place, and they're supplying sediment to the low downstream portions. So 50% of sediment in the Brahmaputra system originates from the 2% of the washed basin draining much of the northern side of the Himalaya. If we focus more on the eastern syntaxis part, we see that similar results. Siang River contributes 41% near the Pretista confluence and 21% in the Bay of Bengal. And using the cesium and lead isotope, they estimated 29%. 75% Siang sediment is from the Namcha Barwa, 75% from these small two peaks of the eastern terminus of the Himalaya, the Namcha Barwa and the Gaila Peri, and the Siang rivers flows in between them. And they use thermochronological tracers to estimate that the 61 to 71%, 70% contribution of Namcha Barwa is the Pasighat sample. So this area, Namcha Barwa, is contributing 60% of sediment here. And it is eroding very faster, 5 to 17 mm per year denudation rates in the Namcha Barwa, coming from 3% of the entire area. So we have right here another sediment tower, which is producing sediment like anything. So we have a globe, then we have a Indonesia, Philippines, and Taiwan, Brahmaputra basin, and then Namcha Barwa, which is significant contributor to the sediment, very heterogeneously. And similar results was found by the cosmogenic tracers. Erosion rates of 4 and 28. So this is eroding very faster. Reasons? Because it has a high relief. The highest elevation and lowest elevation difference is very high. It receives high precipitation, this eastern region, and rapid excavation, means the rocks from the mantle is coming at a higher rate to the surface. The exhumation is higher. If we talk about the sedimentary process, not many detailed studies have been done, but this data come from the ADCP instrument, and they measured the sediment concentration along these transects near the Subanshree Basin. We see how the sediment in the small reach, sediment concentration changes because the river is joining, and there's a small curve here, and the barge formation is there, and along with the transaction, how the sediment concentration changes. I also tried, because this was from the ADCP instrument, I tried to explain this process through the geochemical processes. So I used the secondary data from the sink data that they used for source preparation, that where the sediment is coming from. They also measure the major elements of the sediment, and I used their major element data to determine or examine the sedimentary processes. If we see here, as the monsoon comes, the suspended load sediment and the bank load sediment, chemical composition separation is very high compared to the post-monsoon, the dry season. This points towards as the water flow increases in the monsoon, the potassium-bearing minerals such as mica or biotite comes into the suspension because they have a very platy surface. The shape is such that they comes into the suspension very easily, and increasing the potassium potential in the suspended load. So that the bad scoring might be bad material is coming into the suspension. And this was the evidence of this was found in the another study that the secondary Bourbon's thesis. They saw that in the July, August, in the monsoon season, the biotite, the same mica, the platy structures concentration in the suspended load is higher than the dry season. So it is, and by the way, these samples were taken from the top water of the Brahmaputra, not at some depth of the water. It was collected at the top of the water surface. So the flow of the water is such that it is eroding the bed, bringing the phyllosilicates into the suspension. So if this is in the monsoon, the most of the final material will be seen in the downstream area. If we talk about the paleoclimate, because in the Leonard's study used again the cosmogenic tracers, and they said that the steady erosion rates in Himalaya through late Cenozoic climate changes, but they did not measure any significant erosion due to the climate change. So most of the sediment that is coming from are controlled by the tectonics rather than the climate. However, in the in the deltaic part, the cesium halide isotope, they said that in the recent Holocene, the 11,000 to 7,000 before present, 2.3 billion ton of sediment were deposited in the modern sand because of sea level rise. If you talk about the paleo drainage, this is a very debate is going on whether the Brahmaputra, Sangpo were the one river, or the Brahmaputra captured the river in subsequent in the later stages. Chen et al. Very recent study, it has come in the July only this year. They said that the Ganges arc material, which is found in the Sangpo, in the Tibetan part, they actually drilled the core in the Nicobar fan in the Bay of Bengal. Nicobar fan is little bit segregated than the Bay of Bengal fan and the eastern part. So they hypothesized that the Nicobar fan is a place where the Brahmaputra sediment will be deposited more. So they saw that from 9.2 million years ago, the Ganges arc material is deposited in the Nicobar fan, which proves that at least from 9.2 million years, Brahmaputra and Sangpo were the one river, and exhumation happened after that. So the second model was emphasized here, that it was always a one river, but the northward indentation of the northeast corner of the Indian plate actually uplifted this Namcha Berwa and Gaila Peri, and the focused incision started and the focused erosion started. And it was supported by the higher erosion after that. So this was a thing that I wanted to convey, and from the sediment perspective, if we conclude this presentation, the globally land is being eroded heterogeneously. Two-thirds of the sediment is delivered from the Southeast Asia. Indonesia, Taiwan, and Philippines are the major contributor. And in Brahmaputra, huge load of sediment in Brahmaputra is delivered from the small drainage, that 2 or 3% from the eastern syntaxis. And recent trends of declining sediment flux are observed. which is subjected to the further study, because we do not have a long-term sediment flux data with us. So it would be interesting. So whether in the upstream section also we have observed any decreasing trend. And the sedimentary process have significantly controlled the tracer properties and need to be understood and corrected, the sedimentary process. And the erosion in the sustained is the last cenozoic climate change, and Paleo and river capture, when it happened, we do not still know. Because we said that since 9.2 million years ago, the rivers are one, but there's only one river. But before even that, because they are completely two different rivers in many terms, so were they actually the one river? So we do not know. So it's just subjected to further study. Thank you.
Yeah, I think we move to the next speaker. Professor Mahanta, maybe we should move to Juna.
Yeah. Juna
Hello
is on.
everyone.
Yes.
And thank you, Abhishek, for that very, very wonderful presentation.
Hello everyone. Today I'm going to just start with the Himalayas where the water is stored, and these stored waters are also can be called as the high altitude lakes. I will be showing something like using remote sensing data in the study area where I have focused on the Tawang basin in Arunachal Pradesh, and this has a small basin, sub basin, that is called as Mago basin. And I tried to find out what is the numbers of glacier lakes, not exactly glacier lakes, they are like deviated from the parent glaciers, and now I can term them as a high altitude lakes. Uh, the topic which I'm going to discuss is the inventory and dynamics of high altitude lakes. I have used the data from 1990 onwards till 2018, and it has a gap of 5 years gap, 5 years like circa type, and due to this area actually is basically during the monsoon period, it has a whole cover of clouds. So taking remote sensing data, especially the optical one, it is very difficult to find out, to access the data. So the exact timeline of 5 years, that is has a differentiated, like if it is, I have started from 1990, so the 1990 may have like 89 or 91 data, because exactly on 1990 the data may not be available. So as we know that these high altitude lakes, they are formed in the upper latitude, not latitude, altitudes of the mountain systems. In Himalayas, there are not lots of like high altitude lakes, which have sometimes connected directly with the parent glaciers. That is the main source of water, the glaciers, which are the water towers, and sometimes they have like the glacier recession has led to the vast gap in between the parent glaciers and the lake body itself. So the temperature, global temperature and precipitation, they have like we are observing there are changes in them, and due to this, uh, the eastern Himalayan part and the middle Himalayan part, their the glacier part is decreasing itself. The snow line is going upward to the high altitudes, and thus the lakes are formed. And these lakes they are varied in sizes, like they are sometimes small, sometimes big. They have large storage of waters, and they are like prone to this region, especially the northeastern part of India, which comprises half of the portion as Himalayas, is in the fifth zone of earthquake. So it has a susceptibility to the GLOF, like glacial lakes outburst floods. So the earthquake can trigger to this uh, trigger to the outburst of the lakes, and these lakes can finally as a outburst can create havoc in this the low-lying areas where the like Tawang region has a town itself, a beautiful town, and this can be devastated. And we have examples of like the GLOF activities in Kedarnath in 2012 itself. The situation was worse than ever expected. So it is very important to study these high altitude lakes, and uh, I have tried to find out these high altitude lakes, their numbers and how they are changing in their sizes, not as volume but only the sizes, because this I have just taken the remote sensing data. The field visit is still pending. So we have used the methodology like I have used the land series data. This is a optical data, freely available data, and it has a various series, and thus I have started from, I've taken the data from 1990 as I told, the and taken the minimum snow cover area. The image, the satellite images has the minimum cover of snow, that is I have taken during the like try to take the data from May, June, so that the glacial melt starts. But the difficulty is that the monsoon cover is also, the monsoon and the cloud covers, they are creating like huge problem while selecting the data. Therefore, I have taken this data, and these all are rectified data available freely. And I have used some NDWI. This is a sorry, this is an index run, an algorithm where we use the optical data, the windows of optical data, like we have used this one for, I have shown somewhere the formula here. Oh, sorry. I have forgot to show here the formula. It uses the short wave infrared band and the red band, so that we can use this data. Uh, the algorithm run data, it finds gives us a situation of like pseudo color. We further on processing, we have find out, we try to recode the water bodies and non-water bodies with like 0 if non-water, and water bodies as 1. And then we try to we have done the raster to polygon algorithm, so that we can find out the what are the polygon areas. Actually we can find the areas in the raster format also, but for our precision and so that we can give it as a map form, we have tried to form it to the polygon size. And then we have taken the lake areas which have 0.02 square kilometers, more than 0.02 square kilometers. And this I have cross checked with the Google Earth map. They have the time series maps of that area, and also with some research literature review already done. So we have found that here we can see, that I cannot zoom more than this. Yeah, okay. Here we can find out these are the glacial legs. Is it visible?
Yes.
These are the glacial lakes which I have found out from this process, and these have some several changes and lots of new high altitude lakes. They come up with their small sizes, and we have found out that from 1998 till 2018 there has a slight changes in. Earlier it was 4.213 square kilometer. The numbers were 78 numbers. Then it came down, like some dried up, or maybe the less precipitation during that time, which I have when I have taken the data. And then it again like 4.007 square kilometer. It has again 75 numbers. And then 4.043 square kilometers. It has 76 numbers. Like maybe. Actually, the data with the rainfall and precipitation data and the temperature data is still to cross check with it. So we have found there are, with the check of Google Earth, I have seen there is a difference, like there is a gap in between the glaciers and the this high altitude lakes. Here we can see, uh, it was good if I would have like zoom it more, sorry. So these are the changes we have found, and we can do it more than like after 2018 also. I'll try to do it till 2020. And these lakes, like after cross check with the digital elevation model, I found that these lakes are available between the 4,300 to 5,400 meters above mean sea level, and they are like located close to permanent snow covers, which have started from 520 meters above mean sea level. There are some limitations in doing this work, and these limitations, like we are not easily accessible to those areas, and we have to go with the uh, highly sophisticated equipments to go there and to map the area, cross check with it whether it is the lake area which we have found using remote sensing data is truly corrected or not. And we'll try to do the volume also, volume access of these glacial lakes also. So this is what I have done, like for this water tower and the storage of these waters. Thank you. Hello.
Yeah, thank you, Juna, for that presentation. And I think we have exceeded the time, but it was very, very meaningful. And thank you, both of you, for the excellent presentations following the the uh, the great presentation with Professor Mahanta. Um, Professor Mahanta, would you like to come in and make a few comments at this point before we finally conclude? We are not. Professor Mahanta, are you there?
Yeah.
Could you please turn on your video? Yeah.
Thank you. So we are Juna and Abhishek. You two have spoken. I don't think anybody else is there, no, online. As such, of course, time-wise also we are fine. We can always have a future opportunity. In fact, each of our students can give a full-scale presentation whenever is needed. We'll see that depending on the agenda and in future. I guess NADI conversation, let it continue. Let's have other people coming in. It's a good platform.
Yes.
And we are always there. Hope when things improve, there will be that young scholar interaction that you initiated last year.
Yes.
Where Sabai was there, and I think that's a very good platform to take a integrated collective study. And my suggestion will be that as we tried this time, little different format than what you usually do, because now, because of pandemic, so many webinars are going on. Also today we experimented a new time. So I'm not sure how has been the audience, but I understand that these are also, you are keeping a recording and keeping in the website, is it?
Yes.
So people can later on visit and have a benefit of what we have discussed. Because I could see even Abhishek shared some of his specific research that he's doing. And these are, of course, unlike what you generally do, are very hardcore, specific studies with data and all that. So I am not sure the audience being mixed, but hopefully we can create that sort of an audience also where a good science is integrated with policy, with other sort of engagement into very important topic. These topics cannot be handled just by one aspect alone. It has to be, in fact, most of the time, many of our policies fail because they are not supported by good science. And people later on realize that it was not tenable because there is not good solid background to support it from a scientific, perspective. So sometime if we have an opportunity, more pre-publicized discussion of all the speakers that we have been gathering generally, it could be on a roundtable mode also, that how from the same water conference or general Asian conference perspective, maybe all these people coming together and discussing could be a good idea, to see each other's point and where convergence happens for a better future. I'll stop at that today. I'm sure there will be more opportunities in future. So I know
Yeah,
I'm
thank
not
you.
sure if from audience
Thank you
any
very
question
much.
or anything can
No, no,
emerge.
I would like to make a few closing remarks
Yes,
before. So first of all, a big thank you to you, Professor Mahanta, and to Abhishek and Juna. And of course, to our entire team at Asian Confluence for making this happen, Anabil, Alak, Pooja, and
yes,
uh, and at Asian Confluence, we are looking at water as in our part of the globe uh, as and the rivers as a mountain to sea ecosystem. And I think the perspective of the headwater all the way to the ocean is very important. The perspective of sediment is also very important, I think, and we have to look at sediment. And thank you, Abhishek, for that presentation. I think we also need to get put into the public domain studies such as the one Juna is doing on the lakes. And also we are following up with a NADI conversation series, a 3-part one on the Meghna Basin. This is coming up in the coming weeks. So I think your idea of looking at it, we talked about the headwaters today. If we can look at the estuaries and the deltas and maybe a subsequent viewpoint, how they are affected. If we look at it from an oceanic perspective, how the waters are connected. And then I think if we can look at what is happening in between to the communities and to the discourse, I think it can definitely help the discourse. My last point is that more than the viewership at the current point while the presentation is being made, I think this becomes a repository of knowledge which can influence the course of our future work. And when I say ours, it's all ours together. It's there in the public domain. And I think when we shape this NADI effort moving on, I think all of these elements will highly enrich the agenda setting for the various tracks. And I think on that note, this has been very, very rewarding and important, I think. And we should, without too much delay, follow up with a version which is looking at from an ocean point of view, and as you said, maybe even a estuary and a delta point of view, and also what's happening in the middle. So, which is often talked about more often than the rest of it. So on that note, I think thank you again, and we would like you to like this Asian Confluence channel on Facebook, Asian Confluence, and tweet on hashtag Ascon NADI conversations, so that all of these conversations can build a community together.
correct.
Can build a community together. So please do that, and looking forward to engaging with in the future. Thank you.
Thank you. Yes.
Thank you, sir.
Yes, sir.